A horizontal shift of a cube root equation is solved. So that's why I put right here, horizontal. See the horizon here. And basically, this is a horizontal shift. But think of it this way. I'm cubing the whole quantity x minus 4. There's nothing being added, nothing being subtracted that's outside the radicand. So I'm just going to cube everything to get rid of it. If I cube the cube root, it'll get rid of this here, leaving me x minus 4. If I cube the left side, I've got to cube the right. So 5 cubes 125. And now I have x minus 4 equals 125. We'll simply add 4 to each side. So 129. So think about it. 129 minus 4, the cube rooted is 5. I'm undoing it by doing the opposite. I had a cube root, so I cube. I have a minus, so I added. So here I have the radicand completely by itself on the left side. So to get rid of the 3, cube it. And if I cube the left, I cube the right. Now this negative 5 should be in parentheses here. This negative 5 times negative 5 times negative 5, which is negative 125. Cubes went away here. I have x plus 7. I would undo the plus 7 with the minus 7. And negative 125 minus 7 is negative 132. Well, think about it. Negative 132 plus 7 is negative 125, and the cube root of negative 125 is a negative 5. This one's very similar, except it's a 1/3, so to get rid of it, I would still cube it, the cube of the whole thing. But if I cube the left side, I've got to cube the right. Those go away. So now I have this negative 2 plus 5x equals negative 27. Well, think about it. How would you solve this? Well, wouldn't you add 2 to each side? It's kind of written weird, but we'll still add 2 and undo the negative 2. It's a minus 2, so I add 2 to each side. So negative 27 plus 2 is 25, negative 25. Divide each side by 5, and x is negative 5. Well, think about it. Negative 5 times 5 is negative 25, plus negative 2 is negative 27, and the cube root of negative 27 would be a negative 3. Basically, you still cube each side, and then just do the additional operations that are taking place.